Hello there, everybody. Welcome to Cranky Calculus, and we're going to be talking about the Intermediate Value Theorem. It's a very common sense theorem, but we need to use calculus to go through it. And here it is. And really, I can explain the Intermediate Value Theorem easy as this way. If we're on a plane that starts at ground level at 0 feet, and at some point the captain comes on to tell you that we're at 15,000 feet, which I don't know why they come on to tell us all that stuff. Not like we can control it when we're on the plane. So in order to get from there to there, at some point we had to be at 10,000 feet in the air, which is going to be this value right here. At some point we had to be at 10,000. There's no way to connect these two dots from here to there unless we get through 10,000, and that's what the Intermediate Value Theorem does. As long as our function is continuous on our interval that we have here, those endpoints are not equal, that k value, if it's between the f of a and f of b, in this case, if it's between 0 and 15,000, then there must be some time that we are at 10,000 feet in the air. So let's go ahead and practice this problem here. We have f, so let f of x be 3 over x minus 5, show that there must be a value c between 6 and 8, where f of c is equal to 2, find the value of c. So I already went ahead here and sketched this for you, so you can kind of see what this looks like. If you don't know how to sketch rational functions, go ahead and put in there a comment saying you don't know how to do it. I can make a video and I can show you how to do it. Or even if you know how to do it, you're like, hey, just show me anyway. Go ahead and leave a comment. Really, I'll take anything. So I have my 2 points here at 6 on here and here at 8. And between those 2 points does 2 occur. So first off, let's go ahead and state that f is continuous on my interval from 6 to 8. And that actually is true. You need the interval there because we're not continuous at 5. It's got a vertical asymptote there. But it is continuous from 6 to 8. It's important to note that f of 6, and if I do plug in a 6, I'm going to get 3 over 1, which is 3, does not equal f of 8, which is 3 over 8 minus 5, which is 3, which is 1. And the third thing there is that 2 is between 3 and 1, and so that we can say that there exists a c. We don't know what c is on the interval from 6 to 8, including 8, where f of c is equal to 2. So more often than not, we can't find this actual value, but we can find this one because it is simple enough. We can find this value of c by setting f of x equal to our 2. So we can solve for x on this one. We'll get 3 equals 2x minus 10 when you distribute the x minus 5 all the way over. And you're going to get 13 equals 2x, which means that I'm going to get an answer of x equals 13 halves. So this one we can find out our actual c value. All right, coming down here, we have a little bit more complicated of a problem here because now we're trying to see, do these two functions equal? And we can use IVT, we can utilize it by looking at this argument right here and saying, well, what about f of x minus g of x, which equals to 0? Because there is no way you can solve for this. There's no way to set ln of x equal to x squared plus x minus 5. You can't find that x value without a calculator. So what I'm going to do is I'm going to teach you a little bit of a hack here. What if we just say that, call h of x equal to f of x minus g of x? Even more simplistically, it's going to be ln of x minus, distribute that minus sign all the way through g. So we're going to get minus x squared minus x, change sign, plus 5. So that's what h of x is now, and then our k value is going to be 0. So first off, h of x is continuous on the interval from 1 to 3. Okay, ln of x is a continuous function on its domain, which is greater than 0, and g of x is a polynomial. If you add any two continuous functions, you're going to be continuous, or subtract any continuous functions. Now here's the hard part. We're going to find h of 1. If we're going to plug in a 1 back into here, I'll kind of do that work on the side. We're going to get ln of 1, and then minus 1 squared, minus 1, plus 5. So we're going to end up with 0 minus 1 plus 5. We're going to get an answer of 3. Let's hope that's not equal to h of 3, which that one's a little bit tougher to solve for, so I'm going to do this one in the purple here. So I'm going to get ln of 3, which is something I don't know what it is, minus 9 minus 3 plus 5. So that looks like that's going to give me an answer of equals ln of 3 minus 7. I don't know much about ln, but I do know that ln of e is equal to 1. I know that ln of e squared is equal to 2, and e is about 2.7. So ln of 3 is going to be a number that is slightly bigger than 1. So 1 minus 7 definitely is negative. So we can agree that this is negative. So I think it's pretty fair. I know it's fair to say that 0 is between, I'm going to say h of 1 and h of 3 because I don't feel like writing out the number for h of 3. It's okay to be lazy. It's actually probably for the best. So must this happen? Totally yes. Why does it happen? Because of IVT. You do not need to write down IVT. I just wrote it down just so you can see why. And that is going to wrap up our video here. Do not forget to like and subscribe.